triple students ever you can left. So next class we will continue with triple E. Abhiram, we have next class triple E.
మంచిగా పైసలు సంపాదించుకోవాలా కోసం లెక్క పెడుతున్నారా అప్పుడు వాళ్ళే మన
Okay, once again, all of you. Okay, first we go through the review and then we will continue our next topic. Okay, right. In last classes, we will discuss about types of variable resistor. So first, we think about potentiometers and wire bound resistors. So carbon potentiometers we are used for small rating applications. Next, wire bound potentiometers can be used for high range applications. So more than 2 watts can be we are used. Next, we discuss about what is the LDR and their applications we will discuss. Then after we discuss about VDR, voltage dependent resistor, and their applications. So in the last class we will discuss about the two concepts. First one is a resistance, second one is a conductance. So you can see here resistance is nothing but the property of substance which opposes the flow of electric current. So that is we are called as a resistance. Whatever it may be, the material, it may be conductive material or non-conductive material. So whatever it may be are used, the substance is nothing but material. The composition of atoms we are called as a substance. So that will be we are called as a resistance. Property of a material which is opposes the flow of electric current or electrons through it is we are called as a resistance. Next we discuss about what is meant by specific resistance. That is also we are called as resistivity. That is indicated by means of the rho. The resistance of the material having a unit length and a unit cross section area is known as specific resistance or resistivity of a material. So specific resistance is simply defined cheyalante 1 meter length, 1 meter cross section area means the width, the length, the height will be the same. So at that instant, so how much resistance is offered by means of a material, that is we are called as a specific resistance or resistivity. So we can see here a diagram will be there. So one we are taking the spherical structure. So spherical structure we are called as a resistance. So it is having area 1 meter and the length is a 1 meter and cross section area is a 1 meter. So we are taking as a cubic structure, length, width and height as a 1 meter. So if in these two cases, how much resistance can be offered by means of a material, that is will be we are called as a specific resistance or resistivity. So this value can be changes with material to material because every material not having a constant resistance property. So which is changes even we are selecting the conductive material, semiconductor material or insulating material. Whatever we are selecting according to the materials, at the same time the composition will be decided the resistance value. So we can see here the rho values changes from material to material. So whatever it may be we are selecting the three materials. So simply resistivity can be represented as a rho, but we know the basic thing is the resistance is directly proportional to the length and inversely proportional to the area. So why it will be happens also we have discussed in the last class. If length is increases, the resistance will be added because the resistance composition will be, we are taking 1 meter, which is offers say 4 ohms. Then after we are extending another 1 meter. So then 4 plus 4. The resistance value is increases. So if we are selecting the cross section area, so in case of the cross section area, so enlarging the, there is able to movement of charges from one place to the another place, means the conductivity will be increases. So similarly, when we are reducing the area, so then automatically the conductivity will be decreases, means the resistance property is inversely proportional to the cross section area. So area is increases, resistance will be decreases. Area will be decreases, resistance value will be increases. So these are the phenomena we have followed. So rest of two factors also there. That is a temperature as well as type of material. So these 4 concept is important while we are calculating the resistance value. But in case of the specific resistance, simply we can define the resistance of a material having a length and unit cross-sectional area is known as specific resistance or resistivity of a material. So generally the formula we can write as rho is equals to R by L, RA by L, actually that is a RA by L. So ohm meter is a units. Right, next we discuss about conductance. Conductance is nothing but the opposition to the flow of current is called resistance. So the reciprocal, already we know the what is resistance is nothing but which is opposites, that is we are called as a resistance. The reciprocal of a resistance we are called as a conductance. Resistance means opposition. Conductance is nothing but it is allowing or it is enabling the charges. So that is we are called as a conductance. Conductance is nothing but which is allows flow of electrons. Resistance is nothing but which is opposites flow of electrons. So that we should remember what is the difference between resistance and conductance. So generally conductance is denoted by means of capital G, that is equals to 1 by R. Reciprocal is nothing but it is 1 by, means divisible. Numerator becomes denominator if there is a numerator is available, but there is no numerator and denominator is available. So instead of denominator we are assuming as a 1. So we can write the formula as resistance is equal to, or we can write, but in case of conductance, so G is represented by 1 by R. So next conductivity. So conductivity, so that is a reciprocal of resistivity. So conductivity is denoted by means of sigma. So that implies we are getting the values 1 by rho. So here we are represented with the rho, but in case of the conductivity we are represented with the 1 by rho. So that is a major difference. So then we are substituting the remaining values. So we can get the values as G is equal to sigma A by L. So we are getting here in case of the conductivity. So sigma is equals to G into L by A. So G is a units as the Siemens. M is in meters, area in meters square. So Siemens per meters. So this is the formula we are using for conductivity. So most of the cases not ask about the find out conductance and conductivity. Most of the cases ask about the resistance and resistivity. So those type of problems will be we are discussed here. So this is the most important thing. The various factors affecting the resistance of a material or depends on the following. So resistance values depending upon the majorly 4 factors. So what are those 4? First one, the length of the material. Second one, the area of cross section. Third one, type of the material, and fourth one is the temperature. So these four factors, already two factors we have discussed. So types of material is nothing but the composition it changes from material to material. Because of that reason, the resistance value also changes from material to material. For example, we are taking a conductive material, copper, then after silver, so right, then after aluminium. These are all the conductive materials, but the composition will be different. Because of that reason, so the conductivity will be changes. Gold has the highest, silver is the second one, copper is the third one, so then after aluminum is the fourth one. Means, so these are all the conductive materials, but the resistance value is changes because of the internal composition. That is also one of the factor we are consider while calculating the resistance value. Next, temperature. So already we know that the temperature definitely affecting on the performance of a conductor. So it may be increases or it may be decreases depending upon the temperature. So when we state Ohm's law, we give a statement: the temperature remains constant. So that stick P for the temperature remains constant. But whenever the temperature will be changes, automatically the value of resistance also changes. So these are the four important factors while we are calculating the resistance value. But third and fourth we can neglect, because already we know the material and temperature will always be maintained constant. So if you are taking first and second factors as a relationship, is nothing but length and cross section area. So then we can draw the two equations. First one is R is directly proportional to L. Second one, R is inversely proportional to A. Means the resistance is directly proportional to length, inversely proportional to the cross section area. So ఈ two equations ని మనం simplify చేసి రాస్తాం అనుకోండి, అప్పుడు ఏమవుతుంది, both in the R references. So then we are getting the equation as R is directly proportional. But always the equation should be constant. So means it is in an equation form. So to remove the proportional constant, a constant we should be replaced. So that constant we are selecting as a rho. So that implies we are getting the equation as a R is equals to rho L by A. So where capital R is the resistance of material, units are the ohms. Next, length, L is the length of material in meters. A, that is the area of cross section in square meters, and rho is the proportionality constant. So generally units is the ohm meters. So this is about last week discussed. So in this clip we will discuss about a few problems related to the resistance. So you can see here, determine the resistance of 100 meters length of a wire having a uniform cross section area of 0.1 millimeter square. If the wire is made up of manganese having a resistivity of 50 into 10 to the power of minus 8 ohm meter. So this is our problem. So మనల్ని resistance value determine చేయమన్నాడు. అంటే the R value we should determine. So first we clearly study about our problem. So what we want to discover and what is the data is given in the problem. So first we should determine those things. First, to find out the resistance value, there is a three factors will be essential. What are the three factors is given here? So you can see here the formula R is equals to rho into L by A. So data is given in the problem. First we discover it. So determine the resistance of 100 meters length. So L value is directly given in meters, 100 meters means. So L value is in the problem. So next, rho and A values will be essential. So if there is the A value and rho value is available, so we discover in the problem. So uniform cross section area of 0.1 millimeters square. So means the area also is given in the problem, but units are the not same. Meters in meters is given the length, millimeters is given as a cross section area. Next, third one, manganese having the resistivity. Resistivity is nothing but Rho value also given directly, given in the problem 50 into 10 to the power of minus 8 ohm meters. So first we write the given data. So given data is L is equals to length of conductor is equals to 100 meters. Area is given in the millimeter square. So millimeters నుంచి మనం meters కి convert చేయాలి. So from millimeters to we want to convert meters. So that is multiplied by means of 10 to the power of 3 minus 3. So therefore A is equals to 0.1 into 10 to the power of minus 6 meter square. So just meters convert చేయాలంటే 10 to the power of minus 2. So millimeters to meters 10 to the power of minus 6. So you should remember those things. Okay. So then area we are getting as a 0.1 into 10 to the power of minus 6 meter square. Next rho is equals to already given in the problem. That is a 50 into 10 to the power of minus 8 ohm meters. So as usually we write here. Rho value is equals to 50 into 10 to the power of minus 8 ohm meters. So we find out the R value. So we know the formula for resistance R is equal to rho into L by A. So substitute the values directly. Instead of rho, numerator we are having the rho and L, denominator we are having only the A value. So therefore we substitute the values of rho and L in numerator. So we have substitute the A value in the denominator. So 50 into 10 to the power of minus 8 into 100 by 0.1 into 10 to the power of minus 6. So then if you are dividing this equation, we are getting the value as 500 ohms. Means the resistance value we are obtaining as a 500 ohms. So this type of problems may be asked in the examination. But sometimes some of the quantities is missing. So instead of area, most of the cases, the problem is simplified related to the area only. Length is always common, is directly we can determine. So rho value also sometimes given in the questions. So that is also easy to possible to determine. But most of the cases, the twist will be placed at a cross section area. So for example, you can see the second problem. Find the resistance of 100 meters copper wire, 0.05 centimeters in diameter. But in previous problem directly is mentioned as a cross section area. But in this problem is mentioned the diameter. Instead of cross section area, he is given as a diameter. Take the specific resistance of a copper as 1.7 micro. Micro is nothing but 10 to the power of minus 6. Milli into 10 to the power of minus 3. So 1.7 in micro ohms per centimeter. So first you can see here. So the cross section means diameter given in the centimeters. So resistivity also given in the centimeters, but the length is given in the meters. So means first we convert the all into meters or all into centimeters. So there are majority carriers of the centimeters. So again we convert 100 meters into centimeters. Okay, right. So first we write down the given data. So that is actually 1000. So mistakenly is printed as a 100 centimeters. Okay. L is equals to 100 meters. That implies 100 into 100. So then we are getting a value as a 10,000. 100 into 100. 1 meter ki 100 centimeters. 100 into 100. So that is equal to we are getting as a value as 10,000 centimeters. So 10,000 centimeters. In book is mistakenly printed as a 100. So 10,000 centimeters. So next he give the diameter. D is equals to 0.05 centimeters. Rho value is constant, that does not changes. So we are having in the problem 1.7 micro ohms per centimeters. Micro is nothing but 10 to the power of minus 6. So as usual we write here 1.7 into 10 to the power of minus 6 micro ohm per centimeter. But we know the formula. So to find out the resistance value, R is equal to rho L by A. So but what is the data is here? L is available, rho is available, but A is not available. Means the cross section area is not given in the problem. So just we are assuming in this problem that is the conductor structure is a spherical.